Hi there and welcome. My name is Rebecca Weaver and we're looking at section 6.5, applications of the definite integral today. The average value of a continuous function f of x over the interval from a to b, and that's a closed interval, is defined by the quantity 1 over b minus a times the integral from a to b of f of x dx. Now this is our definition, so we'll use this definition in this next example. Determine the average value of f of x equals 1 minus x over the interval from -1 to 1 inclusively. So we're going to use that definition along with the fact that a is going to be -1, b is going to be 1, and the average value of our function from -1 to 1 of this 1 minus x is going to be 1 over 1 minus a -1, so that's going to be 1/2 out there. And the integral is going to be from -1 to 1 of 1 minus x. We'll just plug that in because our antiderivative is x minus x squared over 2. Evaluating that from -1 to 1, we'll get that our answer is 1. So the average value of f of x is over that interval is just 1. So let's do an average temperature. Now, during a certain 12-hour period, the temperature at time t, and this is time t in hours from the start period, was 47 plus 4t minus 1/3 t squared degrees. We want to know what the average temperature was during that period. So we're going to start at t equals 0. That's our starting, and then we have our t equal 12 as our end. We want the average value, so we'll do the 1 over b minus a, so that's 1 over 12 minus 0. And we're going to take that integral from 0 to 12. That's where it'll be evaluated from of our function. And we'll find that antiderivative, which is 47t plus 2t squared minus t cubed over 9. And then we'll just do our number crunching. We'll plug in our 12 and we'll plug in our 0, subtract those answers, and we will get 55 degrees is that average temperature. Something we're interested in when we take 221 is consumer surplus. The consumer surplus for a commodity having demand curve P equal f of x is the integral from 0 to a of f of x minus b dx. Now, a is the quantity demanded and the price is b. Now, b is just f of a, so you'll get that value and plug that in there. So we have an example. We're going to find the consumer surplus for the following demand curve at a given sales level x. So P is 3 minus x over 10, and our x is 20. So we know that 20 units are sold, so our A is 20. We're going to need to plug in that 20 so that we can get what B is. So we plug that 20 into our demand equation, and we'll get the B is 1. Plugging this into our formula, we have the integral from 0 to a, or 0 to 20, of our function minus b. So it's our function 3 minus x over 10 minus 1. And then we will just compute that derivative, the antiderivative, and evaluate from 0 to 20. And we will end up with our answer is 20, and that means that the consumer surplus is $20. The future value of a continuous income stream of k dollars per year for n years at an interest rate r compounded continuously is the following. The integral from 0 to n, k, e, all raised to the r times n minus t power, and this is evaluated with respect to time. So remember those letters because we're going to have to plug this in. So we have money is deposited daily. Money is deposited daily into a savings account at an annual rate of $2,000. So that means we're putting money in there daily, and it's going to add up to $2,000. Now, if the account pays 6% interest compounded continuously, approximately how much will be in the account at the end of 2 years? Yikes! So during the time interval from 0 to 2 years, it's divided into daily subintervals. Each subinterval is the duration of a day, so that's 1 over 365 years. That's what our delta t is. So we've got all of these t points that we're putting in money in. So we're going to call them T1, T2, all the way to TN at the end of 2 years. Since we deposit money at an annual rate $2,000, the amount deposited during one of those subintervals is 2,000 times 1 over 365, or 2,000 times delta T. If this amount is deposited at time T sub I, the 2,000 times delta T dollars will earn interest for the remaining 2 minus T sub I years. The total amount resulting from this one deposit time T sub I is then 2,000 times delta T e raised to all of this 0.06 times 2 minus T sub I. Add the effects of these deposits at time 1, time 2, all the way to time n to arrive at the balance in the account. So our amount is going to be equal to the sum of all of these deposits plus the interest that this is earning. Now this is a Riemann sum for the function f of t equals 2,000 e to the 0.06 times 2 minus t. You can see that raised to that power there because you could factor that out on the interval from 0 to 2. Since delta t is very small when compared with the interval, the total amount in the account A is approximately the integral from 0 to 2 of 2,000 e raised to the 0.06 2 minus t. We'll evaluate that, find the antiderivative, and we'll get 4,250. Now, that is the approximate balance at the end of 2 years is that 4,250. Okay, so if we are going to find the volume of the solid of revolution, this is our last example obtained from revolving the region below the graph of y equals g of x from A to B about the x-axis, we're going to say, and this is what we need to know, that is the integral from A to B of pi times g of x squared dx. Now, we're just going to use that theorem that we were just given to plug it into this particular example. So find the volume of the solid of revolution generated by revolving about the x-axis, the region under the following curve, y equals x squared from x equal 1 to x equal 2. Now here g of x is x squared, and we can say that the volume equals the integral from 1 to 2 of pi times our function squared, and our function is x squared, so that'll be x to the 4th. We'll take that antiderivative, that'll be x to the 5th over 5. We'll multiply that by pi and evaluate from 1 to 2, and we get that that answer is 31 pi over 5. And that's all we have for the applications of the derivative. If you have any questions, be sure and email me, rweaver10@alaska.edu, and have a wonderful day.